The linear no threshold hypothesis. That's probably the most damaging theory we have in nuclear science and engineering. And it's probably not why you think. It's something completely different. Now let me explain. The linear no threshold hypothesis is simply that if you go from high doses to low doses, the probability of inducing cancer from radiation exposure is proportional to dose. Now, the problem here is that you only see that at high doses. At doses of 10 rem or more per year, will there be any statistically significant increase in cancer probability that we can observe? And 10 rem, that's actually a really big dose. And that's about what it takes just to get a fraction of a percent increase in cancer probability. Now, if you increase that all the way up to about 1,000 rem, the cancer probability linearly increases. And so unless you get a really, really big dose, your cancer probability is not going to increase a whole lot over just what's natural from living on Earth and being a human. There's a certain probability of getting cancer naturally. So even at the large doses of many tens of rem, the probability of inducing cancer is really low. That doesn't mean that it doesn't terrify people. Even when you're below that, and that's the linear no threshold hypothesis. If it's linear from 10 rem and up, then if I extrapolate down to 0 dose, then it's still going to be linear. That's the linear no threshold hypothesis. And the problem is that that is killing people. That sounds pretty crazy, right? How in the world could that be killing people? It is. And let me explain why. That dose of, say, 1 or 2 rem is enough to cause a government to issue evacuation recommendations. And that's what killed the people from Fukushima. It was the evacuation, the panicked evacuation to avoid those moderately small doses in the range of 1 or 2 rem. That killed people. To make it worse, if I go below that, I'm talking tens of millirem. That 10 millirem, that's the annual limit for the EPA on a nuclear facility for off-site releases of, say, any kind of airborne radioactivity. 10 millirem per year. That terrifies people. That happened at the WIPP facility. When they had a release, it was substantially less than that, so it would have been a legal release, but it still terrified people because they didn't have an understanding of the actual risk. And again, unless it's at 10 rem, the effect is too small to see. And when something is too small to see, you really got to wonder what's there, right? I mean, that's the kind of hokey pokey that people play, at least what I've heard, when they start to promote astrology, right? Well, the planets were there and they might be small, too small to measure, but that doesn't mean it's not there. Okay, I can't prove that it's not true, but that doesn't mean that I should be fearful if I don't follow my horoscope. Otherwise, I'm being fearful because of what the horoscope says. And it's a similar scenario here when you're talking about small doses. Case in point, this study right here by Rehu et al., it showed that the major source of death for Chernobyl cleanup workers is fear. They're committing suicide at substantially greater rates than they're getting any kind of radiogenic disease. The fear from that Chernobyl, they're attributing any kind of medical effect to Chernobyl, and so that reinforces their fear, and so they have no hope. People are dying from this fear of radiation, whereas down at these levels that are too small to see. And that's stress. That's not healthy. And that might even cause more cancers if you stress over it. If you get fearful over a small dose because you can't avoid it, because you live in a high background area or whatever. And so, yeah, it actually is killing people. It killed people with Fukushima. It's killing people with Chernobyl. And it's due to fear. That's what the research says. Great review paper here that I did that goes over this and all the other myths. And the linear no threshold hypothesis, it could just be flat out wrong. It could be that we were evolved to be able to withstand this, that we actually need the same conditions that we have here in the biosphere in order for us to thrive. And that means the natural radiation background that we have in the environment would be essential to survive. You can't prove it's true, you can't prove it's not true. It kind of makes sense that it might be true, but that means the linear no threshold hypothesis is false. You can't extrapolate it down to 0. Maybe you can, maybe you can't. Maybe it actually goes in another way. You don't know. We don't know. It's too small to measure, and people get fearful over it, and this fear-mongering is killing people. Again, in the comments, I'll put the link to the Rehu et al. paper. It's killing people.